Gaussian distributions and its probability density functions. So let's see what is the actual Gaussian distributions and why these things actually we need to learn in the machine learning chapter. So okay, let's see step by step. So Gaussian distributions means, just I am taken these examples, just I am zooming these things for better understanding. Just I am taking these examples from the previous data that I have taken the iris data sets, and already we have seen that they have three kinds of flowers, that is Setoja, Versicolor and Virginica. Okay, and just I am drawing it's the probability density functions, and the package that I have taken to draw these functions from the Pythons, that's already available. Just see these pictures, just see these blue pictures, means blue pictures, means this is the Setoja flowers, probability density functions of the Setoja flowers with respect to the variables petal length. Okay, just see the petal length. I have drawn the petal length distribution functions. So this is the similar kind of Gaussian normal distribution function. Just see this thing, just see these pictures. Okay, this is the similar kind of Gaussian normal distribution function. Normal distribution function. Okay, just see this thing, this kind of function. Okay, so the Gaussian probability distribution functions are look like this. Suppose x is a random variable, and if in y-axis, in independent axis, we plot the probability density functions, so the plots will look like this type. Look like this type. Okay, this is the simple probability density functions of the random variable. Okay, so the Gaussian distributions functions, this is the PDF of the Gaussian distribution functions, and just see the in iris dataset, our datasets are discrete type datasets, but we have taken its estimations to plot the continuous. Okay, so the Gaussian distribution functions are applicable when our x is a continuous random variable. Continuous random variable. In short, I am writing the random variable as RP. Okay, so in society, if you just see this thing in practically, we will see the these things, the probability density functions of Gaussian distributions are is this kind of, to predict the height of a human, to predict the weight in various in general, in natural phenomena we will see that kind. Gaussian normal distributions are obey the various kind of natural phenomena. Okay, this kind of thing. Okay, so here the petal length are obeys the Gaussian distribution. Gaussian distributions obeys the Gaussian distribution. Okay, now the question is why actually we need to learn. The question is the question is why do I need to learn about such kind of distributions? Why do I learn about this distribution? Why we need to learn this kind of distribution? So get the answer. The first answer that arises in our mind, that it is a very simple distribution. It is the very simple distribution. It is a very simple distributions. First one. The second questions is to if you just give some these distributions, if you just tell the some distributions of a data sets, then we can easily give some properties of the data. Find some properties. If you simply suppose if a data sets, suppose they are have a huge data sets, I don't know what is data sets, just if you give the distributions of the data, then we can easily conclude some properties of the data set. Easily we can do it. That we will see in the next part of this thing, the lectures. Just prepare with me, just see this thing step by step. Okay, now just I am taking these pictures from the Wikipedia. The probability density functions that you can easily find. Search it on the Gaussian normal distributions in Wikipedia page, then you can easily find these pictures, and they are very easily they are explained these things. Just I am taking these pictures from there. Okay, the first questions is that there have various kind of Gaussian distributions functions, and how these things are plotted. The first questions is this. Just see the first blue one. So there have four Gaussian plotted, and in this plotted there have two parameters. Just you can see to plot this H plot there have needed two parameters. That first one is mu, and the second one is sigma. The mu that is called the mean of the distributions of this distribution, and the sigma that is called the variance of this distribution. The sigma means the sigma square, that is called the variance, and sigma is the standard deviation. Simple the variance of this distribution, and only we need these two parameters to plot this distribution. This is the main advantage. Simple, because of this simplicity, we need only these two parameters. So first, just take the properties step by step. So simple. This is our random variable x. This is the first kind of this is a continuous random variable. And this is the probability density functions of this random variable. Okay, this axis y, probability density functions of this random variable x, and only we need these two parameters mu and. First see these three comes, means that the blue line, red line, and yellow line. First see these things. You can easily see this. If you see this here, actually the mean is for these three curves, our mean is 0. So here. So mean 0 means what? Here actually 0 is here. 0, this one. I'm just little zoom. So 0 is here. This is the 0 point. Just see the mean means the most highest point. Suppose first look the deep blue line. This deep blue line. So in this deep blue line, just see the mean value. Means 0 is here. Here is the 0. Just see the Picard point at the mean. So this is the first observations of the Gaussian probability density functions. So the first Picard at the Picard point, the mean is the point that the most of the value lies on these distributions. Because of this, these points are Picard. This is the first observation. Just see this thing, and also for the red one, mean is here, and also for yellow one, the mean is here. But see this thing, the green line. Here mean is -2. That is the -2 point. That is the -2 point. Here mean is -2, means here mean. That is the -2 point. Here for green line, here it is the mean. It is the mean. Here the mean value. Okay. And just see the now come to the variance part, sigma square part. So sigma square, just first see these three curves. Just see these three curves. First see these three curves. Means for deep blue line, so deep blue line, if we increase the value of the sigma square, means if you increase the value of the variances, then the Picard value has decreases. Means the spread of the curve. Just see this thing. So first our spread is what here? First our spread is here. I'm taking different color. First this is the spread of the deep blue curve. This is the spread of the red curve, and this is the spread of the yellow curve. This is the spread of the yellow curve. Simple. Just if you just increase the value of the sigma square, then the spread value as in. Okay. So in another language, these variance or another language is called the spread or the scale. Spread or scale of the and mu is called the most. Mu is the here most often find value. Most often find the value. This is the mean value. Most often find the value at the mean point. Okay, just see this thing. Just see this region. Just see this region. Just see this region. Most often finding them. So I think you have understand using this simple two parameter. If anyone give just simple these two parameters, then we can easily give some conclusions of this curve. Okay, this is the first. Because of this is the simple, because of it is simple distributions, and easily we can conclude some properties. And in natural phenomena we will see that most of the things are always these Gaussian distributions. So if we just write this thing that I have discussed, so the parameters of the Gaussian distributions are the parameters that we need to draw to draw a Gaussian distributions are parameters of a Gaussian distribution that we need are mu and sigma square. Okay, and plot the random variable that x that obeys in mu sigma square. Here these symbols are means it follows and this n means it's the normal or it is a Gaussian. Is normal or Gaussian. Here this mu means it is the mean of this distribution, and this sigma square, it means it is the variance of this distribution. It is the variance of this distribution. Okay, so the distributions are actually look like this. This is the sample probability density functions PDF, and this is the sample X, means this is the sample random variables, and also it must be continuous. So the probability density functions are here, and this is the mu, and we will see how to plot the sigma, how it is responsible to plot. So such like here, such like kind of here. We will see these things. Don't be confused. So the middle point, the things is the mu. Yeah, this is the mu first, and we will see the variance, how these variance are useful to plot these things. We will see these things. Just bear with. This is the sample. Now the first thing is, if you just give, suppose let's take if we have given mu is equals to 0 and sigma is equals to 2. If we given this two data, then how we will plot this kind of pictures? What will be the actual plot of this? Now let's see these things. So suppose let's take x is our random variable, that follows the normal distributions with sigma with mean mu and variance sigma square. Okay, now the probability of the random variable x with and outcome small x with an outcome small x, these things means it is the random variable, and these things means it's the outcome of the random variable x. This equals to probability of the small x. In short, we have written this using this notation probability that already we have discussed. Okay, many of the author using these notations instead of writing again and again these things. Okay, so the equations of these normal distributions now look like this. So 1 by root over 2 pi sigma 1 by root 2 pi sigma exponential of minus x minus mu r whole square divided by 2 sigma square. This is the main equations of the normal distribution. This is the main equations. Exponential means, don't be confused, this exponential means this exp of x means simple this one. Don't be, in programmatically we have, instead of writing e to the power x, we have written exp of x. Okay, this is the simple equations. Now let's say how using this, how to, if we given this simple mu and base sigma square, then how this plot, how these equations are look like, and how these things are behave, and what is the observations, just discuss, just play with these curves, then I think it will be very interesting. This thing will be, suppose let's take we have the let mu is equals to 0 and sigma is equals to sigma square is equals to 1. Now let's take sigma square 1 means it will be plus 1 minus 1. Don't be confused. Suppose if these things are taken, if we taken these things, then the probability of x, if these random variables are follows these normal distributions, means if we follow these equations, then these equations will now can but 1 by root 2 pi sigma square equal sigma square 1 means sigma is equals to 1, so 1 by root 2 pi exp of sigma square is equals to 1 and mu is equals to 0, so that's thing now will occur 1 by 2 x square. That the thing actually, if we given these two value, only we need to calculate these equations, so I need to plot these equations to find these distributions. Okay, now the thing is, now observe this thing. Now if you just observe this thing from these equations, here our these portions are constant and these portions, these portions, just see this thing, these two portions are constant on these equations, these two portions are constant. So to understand these equations very clearly, now for little time, for some time, we are omit this constant term, because if we just omit this constant term, then it does not change the behavior of the main curve. So if you just omit this constant terms to understand it better and in easy way, in easy manner to behave the curve. So if you just omit this constant term, so then our equations will come like that. Exponential of minus x square. Now let's take this is our y. Let's take, if we omit this equation constant term, then our equations are converted like that. if we omit this constant. Okay, so now the first see the observations first. First see the observations. Suppose let's take first we have using the x is equals to 0, because what here we have taken our mu is equals to, suppose let's take our first taken x is equals to 0. If we taking x is equals to 0, then what will be the value of y? Exponentials of 0 means what? 1. Okay, now let's draw this sideways. Okay, that look like that. Actually, I think I'm doing some mistakes here. Look like that. These curves are look like that. This is the simple mu value, means it has 0. That already we have seen. This is the simple x is equals to 0. This is the simple x is equals to 0, and in this range we got the value here is equals to 1. Y value is equals to 1. This is the y axis, this is the x axis. Okay, if x is equals to 0, then we got that value y is equals to 1. Okay, now we have increased the value of this side. I am increasing the value of this side. If we increase the value of this side, then what happens first? If we increase the value, then what happens? Then x square is also increased. Okay, and if we decrease the value x, means taken the negative side, then so also our x square is increased. For both the cases, if we increase the value of the x and if we decrease the value of the x, okay, then both the cases our x square value is increased. X square value is increased. In first I have taken the positive directions, greater than 0. No, I think it will be better if we taken the greater than and negative. If our x is greater than 0 as well as it is negative 0, then x square are always greater than 0, are always greater than 0. Then I think it will be clear for all of you. Means it simple means if we increase the value of x, x square is also increased. If x square is increased, that means what? X square is increased, that means minus x square is decreased. If minus x square is decreased, that means what? That implies that exponential of minus x square is also decreased. X minus x decreased means exponential of minus x square is also decreased. Okay, from these equations, from these observations, what we will conclude? Just see these things. If we go above, if we just move right or left directions, so from both directions our exponential of minus x square, that is y, that implies that means y, or y value is decreased if we move further away from 0, if we go for left directions or right direction. If we move further, then our y value is reduced exponentially in quadratic form. Just write down the observations, what we will observe here. Just write down this thing. First we will see that our if x moves away from mu, then y value is reduced. Let's see, that already we have seen. Now the second thing that we observe, that our curve, that Gaussian curve, that are symmetric about our mean value, about our x is equals to 0 means mean. Okay, or it is symmetric about mean, is symmetric about mean. Now the third thing is that we have observed here, the third thing that we have observed, as x moves away from the mu, then y reduced as exponentially of the quadratic term x square. So as x moves from mu, then y reduced as exponential of minus x. Okay, because of this I think you have understand the why these things are occur, why these behaves, the curve are behaves look like that. I think you have understand. Now that numerically see the see this thing, how much faster the functions are changing according to a change of our independent variable. Suppose let's take our curve is y is equals to, actually in these discussions I am just avoiding this concept, these two constant terms for easily understand, for easy of our understanding. So in the next lecture we have included to our calculations part, when actually we are going to use calculate our data sets using this formula, there we are included. But to understand these things step by step clearly, I will simply omit this constant term. Okay, so don't be confused about it. So let's take y is equals to, our curve is y is equals to exponential of minus x square. Let's take this is our actual curve. When we have taken x is equals to 0, that means we have got that our y value is 1. When we have taken x is equals to 1, then we have got that y is equals to exp of exponential of minus 1, means what, 1 by e to the power 1, means if you just calculate it in using your calculator, then you can easily got this value 3678 approximate equals to like that. Okay, if we increase something x value, suppose let's take we have increased it at 2, then y must be minus 4, means e to the power of minus 4. If you just calculate it using your calculator, then it will be 0.01. I have already done these jobs using my calculator, then I'm just writing for our time for, so just calculate this value, then you can easily got it. Now I'm just changing this value, x is equals to, let's take 3, then what will be our y value? So this value was look like 0.0023. So just see these things. I am now changing the x's. Just see the pixel that I have changed. So I am now changing the x value to x. I am changing this value to x. So how much amount we have changing this value? How much amount we have changing? So the change here doing this change are near about 20x. Near about 20x, because 1.8 and here 3.36, 20x, because how much, just calculated these things. I am calculated how much changing they have, they are have changing 0.018 divided by 0.36. so just if you just doing this 1 by 20, so the value is changing. Just I am simple 2x changing the 2x value in our independent variable. The dependent variable changing exponential 20x. Now let's see these things. In this step, I am changing this value 2 to 3, means how much? 0.15x. Now let's see these things. How much change here? Actually, it's near about, it's approximate near about 100x. the independent, if we just changing our independent variable 1.5x, the dependent value means our probability or value changes 100x. 100x. This is see these things. That things are useful to predict or probability. This is the main concept. Because of these reasons, small changes of our independent value, the probability are dramatically changed. Okay, this is the main thing. So because of that, our probability density functions for the Gaussian normal distributions are look like. Actually, these things are the similar. These regions and these regions are both the same, symmetrical region. Okay, but the thing that dropping the value, so at the both side of our mean at exponentially in quadratic, exponentially in as a quadratic functions. Just see these things. It's dropping the value as a quadratic form in exponential. See this. This is the main characteristics. This is the main characteristics. How the Gaussian normal distributions are look like. I think you have understand the motto. And also, and if you take an example, if we just go to the case study step by step, then we will see how these things are useful and how the parameters means mean in variances are useful to find the properties of a random variables, means of a set of data. That's if you just simple take the value of the mean and standard deviations, and if our data sets are follows the Gaussian distribution, then we can easily conclude the most of the useful properties of the data set. We can easily conclude. We will see these things in the next part of the